Hey everybody, I'm making this short little video for my calculus class to have a little extra support. You're watching the con video and then you're doing some practice, and I want you to have a little bit extra support in case any of that was confusing. So what we're going to do is make sure that we have the important aspects of the fundamental theorem of calculus, which is considered your most important result for the year, hence the name. Okay, so you have been completing antiderivatives. Say something like the antiderivative of x squared dx, you know to be reverse power rule. You're going to add 1 to the exponent, so that's 3, and divide by that number. You have to add a constant, because when you take the derivative of this, you have to get back to x squared, and the constant's derivative will go away, right? So this is your indefinite integrals that you've been working on, or general antiderivatives. What we want to do is now combine that with the definite integral that we had before, and you had something like 1 to 3 of x minus 5 dx, and you did that geometrically before we left for spring break, and you had the line x minus 5, so that will cross at 5 here. And then if you went from 1 to 3, you would be calculating that area, and your answer would be negative, because remember, it's area above minus area below. So if we called this space the area of this space A, then your answer to this definite integral would have actually been negative A, because it is underneath the x-axis. Okay, so that's sort of what you've been doing. Now let's take that original problem, x squared dx, and let's see what the fundamental theorem says if we want to do that antiderivative, definite integral, from 1 to 3. So now we have these limits, right? We have the same lower and upper limits. You understood from our setup before that we would have the function x squared now, so I'm going to graph that. And if we went from 1 to 3, we would be looking for this area. It's above the x-axis, so we don't have to worry about the sign changing or anything. It's all positive, but we didn't know how to find that before, and we had said before we left for spring break we'd get to that. So the fundamental theorem of calculus is so important and fundamental because it links our derivatives and our antiderivatives. So the fundamental theorem of calculus, in plain English, you watch the con video and you have the big result. It's stated on Khan Academy and in your book like this. If you're going to integrate, do a definite integral of a function from a to b, you find an antiderivative, and then you evaluate between the two endpoints. So I wanted to practice that a little bit with you. So big F is an antiderivative, and it doesn't matter which one. So we don't really worry about that constant, because the 0 is the easiest one to use. A little f, or the derivative of the big F has to get you back to that, okay? All right, so here we go. We're going to compute this definite integral right here. And so I still find an antiderivative. So the definite integral from 1 to 3 of x squared dx, or this exact area of this weirdly shaped, I didn't know how to calculate it with geometric shapes, is I find an antiderivative, that's x cubed over 3, and I use this stick right here to say I'm going to evaluate that between 1 and 3. You can't do it in the same step and not make mistakes. So the first thing we do is find an antiderivative. Now, once I found the antiderivative, remember I actually dropped this sign because that's an integral sign, and I'm integrating it or finding an antiderivative. This right here means evaluate between the endpoints. Okay, so let's make sure that you're writing that right. So I have the antiderivative 1/3 x cubed, and I stick in 3 first, right? It's the upper limit first. So I put in 3 cubed over 3, and I put in the lower limit, a, 1 cubed over 3, and I subtract them. So 27 over 3 minus 1 over 3, or 9 minus 1/3, or 8 2/3 is the exact area under, sorry, I'm out of space, x squared between 1 and 3. This exact area right here comes out to be 8 2/3. Okay, so that's your huge result. You're practicing 4 problems on Khan today, and then you're going to practice 6 problems and hand them in to me. But this video is just designed to make sure to support you making sure that you're calculating the antiderivative, you're evaluating between the two endpoints in the next step, and put the top number in first and the bottom number in second and subtract the two. If this antiderivative has more than one term, like a few pieces to it, make sure you put parentheses around this whole thing. Okay? All right, see you. Bye.